had a pretty large bang associated with the caution and warning now. Okay, so we have an apparent serious oxygen leak.
4, 3, 2, 1.
Houston, we've had a problem. He's in a roll and he can't stop it. Performing an evasive maneuver. Okay, Houston, we've had a problem here. I think we need to do a little more all-weather testing.
Welcome to space.
Hello, listener, and welcome to Failure to Launch, the space history podcast where we take you through every mistake, failure, and explosion that made modern space exploration possible. We are your hosts, Quinn, he, him.
Chris, he, him.
Tenki, he, him.
And a sleepy Chris, he, him.
I swear you've used that one so many times. Sleepy, tired, comatose.
I'm going to squish the life out of you like a grape.
Please.
And today, no, we're not going to talk about something angry or sad like the last few episodes. We're going to talk about something interesting. We are going to talk about the science where rockets and weather collide, launch forecasting. Now, our guest, Tenki, name withhold for NDA... sorry, I'm not going to...
Variety of things,
Yeah.
both my own paranoia, but also NDA reasons. If you're doing anything with launch forecasting, you have to get a security clearance, so this is my paranoia going off.
Doing ITAR but for clouds is, I mean, I understand it.
What
but
is the
just,
cloud that we're not allowed to
there
ship?
There is something unique about American clouds that we cannot risk the foreigners learning about.
Getting abducted by Soviet agents and they're like beating you up and they're like, what type of clouds do Americans get?
Fun fact, the worst time to be a meteorologist was in World War II because all of the weather forecasts were classified information. You were not allowed to publish weather forecasts in the newspaper.
The Gestapo, like German spies sneaking around just like, yay, wonderful weather we're having today. Every soldier's, nope, not engaging.
Then MI5 just throws a bag over your head.
Yeah.
I kid you not, there were secret operations done by what was for World War II specialists to set up weather sites in Greenland. I forget exactly where, and I forget which book it was. But that was an active thing because weather forecasts were considered classified information.
Hell yeah.
I was going to say, I know the I don't know too much about the Allies, but the Germans set up several unmanned posts. They deployed them by U-boat onto ice floes.
Okay, I actually didn't know that.
I'm thinking about how it's like remember how great we used to be, about how it's like meteorologists being like, we used to be super top secret.
We used to build things.
And now everyone gets to know the weather. The samurai are eating slop. How Bushido has fallen.
It's just the end of the Seventh Samurai where you see the samurai sad on the other side as the peasants are celebrating going, our time is over.
It is no longer the hyper specialized. I mean, at the same time, though, like no one would have the weather if it weren't for, my weather app only works because of the human at the other end plugging in the data. I'm not pretending that this is coming from anywhere else. I, at least, Tenki, appreciate the work you still do.
Fuck you, like I don't. I'll beat the shit out of you. The amount of times that, like, I hear from, like, old people where it's like a meteorologist's only job, you could do it wrong and still have a job. And it's like, yeah, well, it's a science, but I mean, the Earth is a complicated lady, and, just...
Yeah.
That phrase I still get periodically, and it annoys the heck out of me.
Yeah, I want to beat up someone with a brick.
Because I would just tell somebody, okay, you want to be the one person who is watching the radar and telling whomever is the range coordinating officer at Cape Canaveral you are good or not good to launch, like, the James Webb Space Telescope? Okay, you want to do that? Have fun.
Smash cut to the screen you're looking at, and it just looks like a Technicolor nightmare, and your job is to understand it and read meaning out of it.
I've had satellite displays up at my former job, looking at the atmosphere, looking at what is called an RGB display, which is basically just a satellite image but enhanced in various ways. And somebody thought I was looking at the surface of Jupiter.
Okay, also, is that RGB the way that I'm thinking of it? Like red, green, blue? Like,
yeah.
Okay.
Think of it as the way that if you're looking at a satellite image, it's just a different way to view satellite data.
Okay, so I know we need to get to this episode, but I'm now curious, in red, green, blue, like RGB, what is being conveyed by each different color? Because I would normally interpret it as just like a linear scale or something, but like red, green, blue implies at least 3 different factors being measured.
It depends on the enhancement that you're looking at. For what I was referring to, the air mass enhancement, it's using 3 colors, but it's doing some mathematics behind the scenes, subtracting different satellite bands. The air mass one uses 5 different satellite bands, or not 5, 3 or 4 different satellite bands in total, subtracting a few of them to highlight specific things.
Okay. So I know we have chatted about this a bit, but just for the audience, something I want to make clear is that as an aerospace engineer, and whenever I was in school for this, whenever I was in training for this, the thing that they always told us, and like a lot of our calculations, a lot of this aircraft design is, you assume stuff because there's something called turbulence and there's something called the Reynolds number that you basically cannot, it is incredibly difficult to properly simulate and account for. Turbulence is, in engineering terms, basically just like a zone where things are happening. It's like an electron. Maybe it's there, maybe it's not. We know it's vaguely in this zone. And correct me if I'm wrong, meteorology seems a lot like trying to read meaning into turbulence, i.e. incredibly difficult.
Oh yes, it's difficult. The atmosphere itself is impossible to perfectly model, and that was known back in 1963. The entire term chaos theory and the butterfly effect comes from attempts to model the atmosphere. I forget the guy's first name, but Professor Lorenz back in 1963 attempted to run a numerical model, took to save time, took the direct output from the model when he entered the initial conditions, reran the model, and because there was a 0.03% difference in the initial conditions he entered, the model output was entirely different.
Hell yeah. I also love that, like, chaos theory and like the butterfly flapping its wings and causing a hurricane on the other side is like a meteorologist's attempt to explain how difficult meteorology is to non-experts. And that kind of just like kept going.
A quote from one of my professors in grad school was, "The more you learn about weather models, the more you're shocked they work at all."
Just everything is bouncing on a knife edge.
Yeah. Is it a lot of assumptions and just kind of like, we're just going to assume this? Because a lot of engineering aerodynamics is the same way of just like, close enough, let's just lock this number in. It's never going to change if I believe it hard enough.
A lot of assumptions just so that 1, the math works, and 2, the models run fast enough so that you can actually use them.
I imagine, that's got to be the trade-off of like, you can attempt to get it more granular if you're willing to wait a few more hours.
The smaller you get granularly, the longer it takes, and it increases on an exponential level. If you decrease the size of the grid space you're working with by 2, the amount of time it takes to calculate goes up by a factor of 4, and it is exponential.
So, Tenki, again, thank you for coming on, and thank you for being willing to talk about this stuff and educate our audience on just from like the few minutes already sounds like an incredibly interesting niche of the space industry that people do not know enough about.
Yeah. Launch forecasting is tough. The interaction of weather with rocketry is difficult. I got interested in it at an early age. I initially grew up in Kansas, which is how I got interested in weather. Kansas gets everything except for hurricanes. And by weird fact of where a weird rich person lives, there's a massive museum in Hutchinson, Kansas, just outside Wichita, that has a whole bunch of artifacts from the space race, both U.S. and one of the largest collection of Soviet artifacts in the entire country.
Really?
Yeah. The Hutchinson Cosmosphere. They have 2 of the 3 Mercury, Gemini, Apollo missions that went nearly catastrophically wrong. They've got the Liberty Bell 7 capsule there, as well as the Apollo 13 capsule. The only capsule they don't have where the mission nearly went horribly wrong is Apollo 8. And I have to imagine that
I think you mean Gemini 8 for that one.
Gemini 8, yes.
Yeah, the spin cycle.
Yeah. I have to imagine if they asked the Wapakoneta Museum if they could have it, it would just be this loud cat hissing noise.
Okay, I have to go check that out.
The Hutchinson Cosmosphere is one of the few reasons to visit Kansas.
I don't, if this museum is free, I'm not going to tell you, audience. I'm going to tell you the ticket was like, I don't know, $1,000. That does sound so interesting. And I love a museum that is just like, our claim to fame is that we have all of the disasters. We have the carbon lump of Vladimir Komarov.
I don't think that's their claim to fame. That's just a funny thing I noticed when I looked it up.
All right, that's fair. I shouldn't embellish that.
But combine that with me growing up when the space shuttle was basically in the era between Challenger and Columbia, I vaguely remember the first clean images from the Hubble Space Telescope being made public. And like that pilled me on space early on.
I think I've told it on this show, but I will always have this memory of whenever I was a little kid. Yeah, I was really interested in space. I was really interested in keeping track of all of these missions. And, you know, relying on my parents for like, hey, can you find this out? Can you find out what's going on with this one and that one? And we were driving somewhere. I was sitting in the back of the car. My mom was sitting up front. And my grandma was sitting in the passenger seat up front. And my mom had been trying to figure out how to tell me about the Columbia disaster. And my grandma leans over, tells her, like, did you hear about that shuttle? Turns back to me. It exploded and they all died.
Oh my God.
And apparently we did not make it to church that morning. I was crying too hard and we went home.
Yeah, fair.
What pilled me on space is a good one. We can.
That could be a fun, yeah.
I'm trying to think, where did it all start?
The poop bag?
Not the poop bag. When I was a child, it was probably being exposed to, here's the stellar bodies. And I just thought they were cool.
Hell yeah. I had the thing where I was never as interested in, and I should have been, I was never as interested in like planets, in the actual cosmos, as much as I was the engineering of going to space. I was more interested in like rockets and spacecraft than the things they were going to explore.
I think it's just because it's like they are places with names and potentially could be mapped, you know?
Yeah.
I mean, it's a multifaceted thing that pulls people's interest. Early on, like, yeah, I was fascinated with zero-G floating, but also all the information from the Voyager probes was just getting collected and being put in a format that was easy for young kids to actually read. And early kindergarten, I remember being so annoyed that I couldn't go off of the kindergarten shelf just so I could check out the books that were about the planets.
Also, just like if we're talking about different celestial bodies, just the fact that like so many moons, especially around, you know, well, Jupiter and Saturn, they kind of have it easy. They have like
the lion's share of the moons.
Yeah. But so many of them are interesting. You know, you got Europa. Io's always been my favorite.
Mimas is always looking at you.
I was just looking up Mimas because I knew that was a favorite of yours. The one with like the giant Cyclops eye that looks like the Death Star.
Oh, right. The Death Star moon.
In my like 400,000 photo collection from Cassini. Yeah, plenty of Mimas looking at you.
Hell yeah.
I'm very fond of Enceladus.
Oh, right. Yeah.
I just think Enceladus is cool.
Oh, yeah, that's a cool one.
I've always been fascinated by Triton. I wish there was a program in place to get something like Cassini out to Neptune.
Yeah,
even though I know that's never going to happen in my lifetime.
Man, yeah, Triton is not a favorite, especially whenever I plug this into Google Images and Triton, first picture, the moon, second, Forgotten Realms wiki, third, Triton mythology, yeah, fifth, Little Mermaid wiki, yeah. Sixth, Mitsubishi Triton. Yeah, not the favorite for the fucking... Oh, that's a shame. We need to bump up Triton's numbers.
And we only have like 4 different pictures of it because that's all they could take.
Like, I know there has to be a scientific reason, but I do wish we could just do a mission to all the unloved moons, you know? Just mapping it, just out of pity. You know, we should get to look at them.
All right, we're gonna. I was about to bring up, like, okay, what's a lesser known moon that people don't think about? which I mean, I guess it's
Charon, my homie.
Moonlit, but Daphnis.
Miranda, any of the moons around Uranus, both because they're named after Shakespeare characters, but also because Uranus just kind of, all the brain processing around Uranus goes into the jokes about the name and the fact that it's orbiting on a tilt.
I don't know, I definitely have sent you these photos before, which is why they're coming to mind, Quinn, but like Daphnis is the moonlet that's plowing through A ring, Saturn.
Oh yeah, the kind of like the shepherd dog of the rings.
Yeah, its presence has like disrupted the ring dust, so there are like ridges in the ring around where it passes.
We do need to do an episode where we all just like get a bunch of guests in and everybody just records like a 10-minute spiel about their favorite moon, just like finding the most obscure. Like I can't remember, I think it's an asteroid, but like one of the highest peaks in the solar system is this massive, like higher than Olympus Mons mountain on a tiny little like couple of kilometers asteroid, and it's like the only noteworthy feature of this thing. It's like this asteroid is like 40% crater, and in the middle of that crater is like literally one of the highest peaks around.
I will forever stand Charon. I respect a moon that can bully its planet. I know, right?
Yeah, the fact that like Pluto is almost two moons orbiting each other, and it's like only slightly bigger.
Yeah.
It's its own mini system.
New Horizons made me so happy.
Yeah. Also, audience, if you enjoy Failure to Launch and want to get access to more of it, consider supporting us over on Patreon. Signing up at any tier gets you access to a monthly bonus episode, and signing up at higher tiers gets you access to more bonus content, as well as your name at the end of every episode.
I'm going to ruin our momentum all over again. We joked about it, but we didn't actually do it, and we have to do it now. Tenki, favorite cloud?
I would say either nacreous or lenticular. Both of those are kind of weird or obscure ones. Nacreous clouds are high-altitude stratospheric clouds that are almost all ice crystals that light up in all kinds of different colors when you look at them.
Wait. Oh, yeah, that's based. Okay,
it's fucking cotton candy. This is so cool.
Yeah. Lenticular clouds are the ones you see around mountains. So the ones that look like UFOs. What happens is when air goes over a mountain, it is disrupted. It gets disrupted and made turbulent. You have gravity waves in the atmosphere that form as the air goes over the mountain. And right at the top of that gravity wave, you see the cloud form. So it looks like a circular UFO that has a curved base up that's just formed directly along that wave. I don't know the exact physics to try and explain it.
So I do need to ask and clarify, because that is very interesting. And like, obviously, as like a mountain, that's a low, it's both more altitude, but also a load more mass in that immediate area. Gravity obviously pulling down harder in that kind of zone. And you're saying the formation of these lenticular clouds is due to the additional gravity in that area more so than the atmospheric conditions, right?
It's not due to that. Gravity waves are called gravity waves because gravity is the restoring force of them.
Oh, okay.
But the wave stuff is stuff that I don't know how to best explain.
Okay.
Because I only got a master's, not a PhD. I looked at going into research and went, nope. I would go crazy.
Okay, well, we're also reaching our first point of conflict, because you cannot name a thing gravity waves, because that's like, gravity waves are a thing. It's a physics thing. So of course I'm going to latch onto that. And of course I'm going to think that mountains have cool gravity wave. Still though, those are wonderful answers that, yeah, like you said, a little obscure, but significantly cooler than every kind. Why don't people advertise this more? There has to be like better science education for clouds, because everyone's like cirrus, cumulonimbus.
I will tell you what mine is. My favorite type of cloud is asperitas.
Asperitas. I don't know that one off the top of my head.
Oh, fake cloud.
Clouder.
Okay, no, you are okay. I did look it up, and Chris, you were not lying. You did not make up a cloud to sound smart. Okay, this just looks like snow. This just looks like a snowfield on the sky.
Okay.
It's like if you were under the water looking up at the waves above you.
Part of a altocumulus to stratocumulus, so still lower level.
Dude, I love the clouds. I mean, it says formerly known as undulatus asperitas. I love that we give clouds kind of like Latin species names.
I love how we have a cloud that is FKA.
Look, meteorology is a field of people who are massive geeks.
Hell yeah.
Like, it's going to happen.
Do you get to name a cloud if you discover it? Like, are there clouds, to your knowledge, named after the meteorologists who, like, discovered or first noticed and, like, categorized them?
Not to my knowledge, no. I don't believe so. So, unfortunately, it's not going into full species territory where people are able to name a species after, say, Stephen Colbert.
Damn it. Tenki's cotton candy would be such a cool cloud name, though.
I mean, the word Tenki is the Japanese word for weather. Like, I am a recovering weeb.
So that is just weather forecast with, okay.
Yep.
How about your favorite cloud, buddy? Because I can tell you mine.
Go ahead.
Oh, Arcus clouds, all the way. The ones that are just right in front of a derecho.
Oh, yeah. Yeah, shelf clouds, anything like shelf clouds, roll clouds, anything like that.
Just
that looks cool.
The wall that heralds the end.
I was going to say
yeah.
that is definitely a second for me, because my first thought was going to be like, I've seen enough like shelf or wall clouds in my life. I'm like, this is really cool phenomena, guys. Look at that cloud, because I'm assuming it's like a cloud that's basically riding along a front, right? Like between a cold and warm front, and it's kind of just like stuck there. Am I just insane? Am I wrong?
Guys, we occasionally have to talk about rockets.
I forget the mechanics behind how shelf clouds form.
But you know what what clouds have an impact on? Rockets.
Whoa.
Oh, yes, they do. Oh, yes, they do.
My favorite is Stratus, if only because whenever you go on a plane and you like take off and then you fly through clouds, it's always really cool.
Fair. Absolutely fair.
Welcome to the Cloud Podcast.
Worst derailing on the show, I think, because the last time we did something this bad was Sea Dragon.
Yeah, we are today going to be talking about the science of launch forecasting. So, Tenki, take it away.
All right. Well, I did put together a series of slides that are going to be put online. These are slides that I'm preparing to give as a talk for my current job to just talk about the difficulties of being a launch forecaster to other meteorologists. So these are a very broad scale overview. I'm not going into detail about any given launch site in terms of the local effects, the mesoscale effects, both for not to overwhelm people, but also because I don't know those as well as the people that are actually forecasting for those sites. But in terms of modern day observation of weather support, I pulled a quote from an interview given to weather.com. To quote, "Launches rely heavily on the weather. The U.S. Space Force 45th Weather Squadron, based at Patrick Air Force Base near the Space Center, is responsible for launch day forecasts. Quote, statistically, any given launch attempt has a 1 in 3 chance of scrubbing, Squadron Launch Weather Officer Melody Lovin said in a recent email. Of all launch scrubs, half are due to weather at Cape Canaveral." And on the slide, I have a picture from August 29th, 2022, before the Artemis 1 or Space Launch System launch, of 3 towers surrounding the launch complex of the SLS with a lightning strike directly onto one of the launch towers.
So just kind of going off of that. So first question, you mentioned that the 45th Weather Squadron are the people who do the launch forecasting. Is there a difference between doing the launch forecasting doing the launch day forecasts and deciding to scrub a launch? Like, are those handled by the same people, or is it the squadron does the forecasting and then provides that to the actual, like, the people handling the launch?
In my experience, the meteorologist does the forecasting and the decision is made by the range control officer or the director of the launch.
Gotcha. And it says, okay, so of all launch scrubs, half are due to weather at Cape Canaveral. Is that just because of, like, well, obviously different sites have different kinds of weather conditions. Is Cape Canaveral just really bad for that?
Cape Canaveral is just really bad. There is a slide later that shows some of the reasons that Cape Canaveral is a really difficult area to forecast.
And another thing I wanted to mention, because audience, you may have seen these in a lot of photos of like modern rocket launches, maybe not as many in old photos, of big towers. A lot of the time, like Cape Canaveral, it's 3 big towers around this launch site. Correct me if I'm wrong, those are lightning rods.
Yep, those are lightning rods. They're set up to pull lightning away from the rocket, both to protect it during launch, but also protect it while it's on the pad.
I must ask the low-level question of what types of things would happen if the rocket were struck by lightning?
Fueled or unfueled?
Well, I mean, it's ready for launch, isn't it?
Do you want the thing full of explosives? to get thwacked by a lightning bolt.
Well, in one example, we can actually go to the next slide because we have an example of that.
I hate a slide that has a before and after in the title.
Oh, Christ.
The next slide, this would be Apollo 12 from 1969. On the picture on the left, you see a picture of Apollo 12 launching into what looks like it's a cloudy day, but it doesn't look ominous. It doesn't look terrifying. And the launch goes successfully. However, exactly 36.5 seconds after launch, something happened. A giant sound struck through the rocket. Quoting from the voice recording from Dick Gordon on board for Apollo 12. What the hell was that? Pete Conrad. Huh? Dick Gordon? I lost a bunch of stuff. I don't know. Turns out, Apollo 12 was struck by lightning. Twice.
Wait. Twice.
Twice.
In quick succession or over the course of...
In quick succession.
Okay.
In very quick
Mother
succession.
Nature just tried to double tap a rocket.
The second strike occurred at 52 seconds after launch.
I love the second picture that just has like the lightning kind of just crept in from the side. Also, like the old quality of the photo just lends it that more like cryptid element. Okay, wait. We're going back to meteorology for a second because as a child, like this type of stuff was like spooky to me because it's like I was and still am deathly afraid of tornadoes. They are like things. They're not just a weather phenomena. They're monstrous things.
Oh, justified.
They are malicious and they hate me personally.
They are malicious, yes, and they hate me personally. But it's like that same kind of vibe seeing just the lightning.
Individual for tornadoes?
I initially grew up in Kansas. Trust me, I know your fear.
I know that you have an excuse though because you live in Kansas. I'm like, how did you survive? But I grew up in New Jersey, so the worst that I'd have to experience is like maybe a hurricane or like a lake effect weather. Like New Jersey was not a place.
Superstorm Sandy from 2012.
Also, audience, we will try and have this out on YouTube as soon as possible with release. If you are not on YouTube, I would highly recommend looking at the PDF or PowerPoint in the description, however you can, because these images are great. I also love the second image, for me, mostly because there are so many pictures of this exact scene of the launch tower, a lot of smoke, and then something bad happening. This is exactly the same photo of, like, the Nadellan catastrophe as it's happening. Intelsat 708, I might be getting that number mixed up. There are so many pictures of this exact scene of the tower, smoke, and something bad happening.
Speaking of Nadellan for a second, I really wish we had just the split-second frame of the general just on the chair watching the rocket detonate before being consumed.
Oops.
Jeez. Yeah, I will safely say that any kind of launch support is not taking place just outside of the launch in a lawn chair.
Oh, yeah.
Both because you can't really look at weather data doing that. Also, if you are that close to a Saturn V or the SLS, you will be liquefied.
Nadellan would have been the kind of guy to just send someone out there with like a little propeller on a stick and just like, yeah, get the weather for us.
Wouldn't they have just sublimated instead? Like, they would have just been turned...
They skipped a phase, yeah.
We're skipping liquefaction. We're going straight to becoming a gas and being dispersed immediately.
The last thought running through my head is, like, this little mental debate over whether I am being liquefied or sublimated. And just kind of like, wait, well, because, yeah, like, me in this situation... the person near the rocket in the Nadellan catastrophe is a highly qualified rocket scientist and has that like, well, you know, actually, theoretically.
The millisecond that stretches for eternity.
It's the fucking getting shot scene in Sherlock, except it's just trying to figure out whether he's being liquefied or sublimated.
Oh my god.
So I also did have a little bit of a history interjection here.
About getting shot?
No, about Apollo 12, because, so the crew did know, like, the crew knew that they got struck by, or I don't know if they got struck by lightning. I know there was communication once they were in orbit of like, hey, we think you got struck by lightning. The crew, they were worried that NASA was going to scrub their mission, but they did not know about NASA's worries for the spacecraft. Specifically, that the lightning strikes may have fried the capsule's parachute release mechanism. And the reason why the crew didn't know is because NASA refused to tell them.
Mm-hmm.
And for this, I'm going to quote space historian Andrew Chaikin's book, A Man on the Moon, The Voyages of the Apollo Astronauts. Quote, "What Mission Control did not tell Conrad was that they feared the lightning had damaged the pyrotechnic system used to deploy the command module's parachutes. Chris Kraft in Houston had conferred with other NASA managers at the Cape, and they decided to continue the mission. The rationale was simple. Conrad and his crew would be just as dead if the parachutes didn't work now as they would coming home from the moon, 10 days from now. So basically just like, well, if the parachute's fucked, they're already dead, so let's just not tell them."
Yeah.
Yeah, it's a bad cover-up, and these guys deserve to know. On the other hand, and obviously it didn't wind up being an issue in Apollo 12. On the other hand, these are right stuff astronauts. If you tell them the parachute is fucked and they're going to die, they are going to sit on the moon in a lawn chair and just wait until their oxygen runs out.
Pretty much.
They are going to have fun with it.
Apollo 12 was one of the most dudes rock missions of all time.
I'm telling you, this is why they should have had the wine in the little sippy bag.
Dude, the guy left behind in the command module would have just been like, no, I'm landing with you guys. I'm walking on the moon.
He will find a way to wheelie the moon rover.
Yeah.
During the mission, Pete Conrad, Dick Gordon, and Al Bean were all pranking each other at various points. Heck, their backup crew snuck pictures of pinup girls into their mission calendars. It was the most dudes rock mission of all time. If they knew that there was a chance they would die, their response was, "Oh, we're going to the moon anyway, screw it."
We're already up here, let's go.
Yeah, it's just the fallen astronaut memorial, except it's all three guys posing their own corpses in fun and interesting ways. They're just like, you just reach the moon and there's three corpses in spacesuits sitting around a rock with like a couple of cards laid out like they were playing poker.
Honestly, Pete Conrad would have done that.
Just all laid around a single rock, praising it.
That is the issue, and the same thing with the Soviet Union. Like, the cover-ups are bad, A, because they are denying information of people who really deserve to know it, but also B, because those guys they wouldn't have changed their mind anyway. These guys were test pilots before. They were going to die.
Yeah.
They probably thought they were going to die doing their job. The fact that, like, some Apollo astronauts are still alive today is probably a surprise to them.
Well, just
honestly,
wow, I didn't expect to live this long. What do I do?
It's just like sitting on his deathbed, just like kind of anticlimactic now that I'm thinking about it. Not the explosion I was just like...
There's still time. There is still time.
98-year-old Apollo astronaut just like, hey, can you just like set off an explosive underneath my hospital bed?
Can you attach me to a sounding rocket and just let it rip one last time?
Oh, man. So going back to the lightning strike, what exactly happened? How did this happen and why? Considering that they were given the all clear to launch, weather forecasting, it looked fine. Like, people weren't concerned. Why did that happen? Well, the problem is there was a cold front that had gone through in the night before. It was overcast the entire duration of the countdown. They launched into water clouds that were about 8,000 feet deep that were just above the surface. There wasn't any ice. It seemed fine. The way that lightning forms is there's a charge separation that develops within the cloud. The way that the cloud gets electrified, in a sense, is the negative charges and the positive charges get separated by the act of the cloud just kind of being turbulent and convective. And when the rocket launched through, it provided a way for the lightning to travel down to the surface easily without needing to form in a normal manner. This is what is referred to as triggered lightning. It's triggered because the rocket is traveling through it. And that's what caused it.
The rocket upset the lightning, and so the lightning attacked it.
I'm loving the developing bit of Chris has to personify everything in nature into some evil monster.
Think of the Saturn V as an extended middle finger going directly through the cloud.
Piloted by the three most dudes rock men imaginable.
all with their middle fingers up too.
Them doing it too.
Yeah. We have fingers inside of fingers at this point.
Everyone on the ground silently praying with a middle finger up, just like everybody doing Hasadiga Ibawai fuck you God.
Yeah. So that's Apollo 12. If we can go to the next slide, why is weather support so important? And the first thing is, rockets are giant, complicated metal machines filled with explosives.
Built to defy God.
Liquid fuel, solid fuel, these are giant explosives. They're riding on top of a giant explosion. and failure of one small part can cause a cascading failure of the entire rocket. I don't know the exact number of parts in a Saturn V, but even the failure of 0.01% of the Saturn V parts is a failure of something on the order of 30 to 300 parts.
Oh yeah, I'm remembering that quote. Someone was asking someone at NASA, like, hey, can we expect like 99.9% reliability, 99.99, whatever? And he was like, yeah, that's still going to be like a couple thousand parts.
And there's another problem. The atmosphere is incredibly poisonous to rockets. The photo I have on the slide is from the Rogers Commission report about the Challenger disaster, showing where the O-rings are. The examples are the Space Shuttle SRB O-rings. The failure occurred because the O-rings were not designed or tested to go below freezing temperatures. And when it happened, they shrunk too much, and that allowed gases to pass through the rocket boosters and destroy the shuttle. But you have additional problems. You have salt spray and corrosion. A lot of launch sites are located in the tropics, and the tropics are the most corrosive place on the planet. You have sustained elevated winds, you have salt spray, you have a lot of heavy rain, and water is the universal solvent. Water likes getting into things. Water will get into things, and water has this fun thing called reaction. Hydrogen bonds, hydrogen reactions, and it starts rusting everything. So you want the rocket to be in the atmosphere as little as possible, because the atmosphere will do very bad things to it.
I think we do need to give nature some respect, because we are big fans of hypergolic fuels, hypergols, all of that stuff. The stuff that will melt your skin, and that's the fun, interesting, that's the hype. But the old classic, nature will just destroy everything. And I think we need to respect that. I also just love the idea of like a hypergolic rocket, like launching out of China, say, where the inside of the rocket, incredibly corrosive and toxic and horrible. The outside, the jungle environment, incredibly corrosive and toxic. And just like, this should not be. I work in the space industry, and I'm now realizing that, hey, maybe this is like an affront to, I don't know, I'm not a religious man, but just, just like, you know, what should be.
One of the logistics involved with any rocket launch is basically taking a shelter with it. If you're going to a remote site, there's a shelter that is put around the rocket until it is time to launch.
Yeah.
The rocket does not want to be exposed to salt spray flying at it at 30 miles per hour, sustained for hours on end, because you're in the tropics.
If you think about it, it really is just a case of dueling corrosion. You have the bad stuff on the inside, the bad stuff on the outside.
What's going to break through first? Oh, it's a power struggle. If the water gets in, it's going to run into UDMH and just start like, I actually know that probably, yeah, if the water ran into hydrazine, that would probably be very bad. Yeah, forget I said that.
Mm-hmm.
Oh, yes. That is actually on the next slide. Among some of the hazards to rocket launches is lightning. Lightning plus rocket fuel equals, quote, fun.
Hell yeah.
At least if your idea of fun is what turned Nedelin from a human being to a pile of mist.
That is my definition of
His
fun.
constituent atoms scattered across Baikonur.
They say you can still get a little sense of him when you walk around Kazakhstan.
He's been dispersed across space and time.
Any kind of rocket fuel has very interesting interactions with lightning, because a lightning bolt is as hot as the surface of the sun. It is a plasma. It does bad things.
I love plasma.
I was to say, to bring it back to water for a split second, just ice itself is also the big bastard.
Oh yeah. Ice is heavy, ice sticks to things, ice will just actively damage everything.
Yeah. One water infiltration.
There's a brainworm. There's a brainworm coming. Wait.
Oh, God.
Stomp it before it gets away.
Oh, no.
A culture whose funerary ritual, like, you know how like people cremate their loved ones and spread their ashes around as like we're dispersing you all over so you can be nature,
right.
or whatever.
When an elderly engineer in Baikonur gets too old to work, he just stands underneath the Soyuz.
We're gonna crank that up to like 13 here, and it's like their funerary casket is at like in the pod on top of a rocket that's full of like the spiciest hypergols imaginable, and then we set that baby off and explode him, and just disperse everything, just atomize, spread everywhere.
You don't need to do that with the rocket, though. We've just established if they just tied your corpse to the top of the lightning rod by the rocket, the plasma would just zap that.
No, but that's the point. The hypergalls is like it's like having your incense and your holy water and
creating a new religion celebrating explosives.
Getting let through the pearly gates, but only because no one wants to get close enough to actually stop you.
Little do you know that at the top of all three of those lightning rods is a death engineer with their fingers up. Taunting nature.
In terms of taunting nature, temperature. The next question is, can the rocket structure handle freezing temperatures? We learned in 1986 that the space shuttle specifically could not.
That's in a way they're a lot like us too. Like we can't.
Yeah, if you're cold, they're cold.
Skin.
Let them in.
Yeah, yeah.
Look, some people can. I know a number of people who wintered over in Antarctica. They have reached a point where negative 30 is considered warm.
Yeah, your nerves stop working, and then it just becomes a lot easier. The trick is to get, like full body frostbite. It's kind of like a tan, You have to get like a 3rd-degree sunburn right as fast as possible, and then you're tanned after that.
Yeah.
Humor, sarcasm, not to be taken as a legal or binding recommendation from the hosts of Failure to Launch Podcast LLC.
Yeah, if you're in an area where you have a full-on Arctic airburst, don't go outside without protection. It's a bad time. You will not enjoy the no-expenses-paid trip to the hospital.
I don't think that anything good will come from a phenomena that is referred to as airburst.
That can be fun.
Yeah, we could get to that at one point, but an Arctic airburst specifically referring to a giant mass of Arctic air moving over some area of the continent. Think of it as the polar vortex, like whichever way you want to think of it.
So something that will make the Antarctic even colder than it normally is, I imagine, within that area.
Oh, yeah.
Wait, I had another thought. There's another worm. A good one this time. It's meteorology related.
Yum.
So I'm looking at the lightning rod tower, and clearly the rod part is different than the tower part. The structure is just there to move it up, but is lightning more attracted to things that are shaped specifically? Because I see that it's got that spirally shape to it.
It's more that lightning tries to find the easiest way to get to the surface. The atmosphere always goes for the easiest way to equalize or to get rid of a distribution in voltage. So it goes for the tallest structure. So the lightning rod extends up, and as to, I don't know the construction for lightning rods, I would expect that the main goal is that the way the actual rod itself is set up is different from the surrounding tower to not damage the tower, but it is grounded to the earth so that the charge is able to distribute amongst the ground without damaging the additional structures. But that does get into one of the next hazards, surface winds. At what point will the launch structure be damaged by the winds of the environment? The picture I have on this slide is from September 26, 2022. The SLS launch was scrubbed by Hurricane Ian, and they ended up moving the entire structure back to the vehicle assembly building. And that was a tough decision, because deciding to remove the structure is you are delaying the launch by another 2 weeks because of how long it takes the crawler to get the vehicle from the launch site back to the VAB, and from the VAB back to the launch site. But any environment, any launch structure is going to have wind thresholds, because its amount of wind loading stress, its amount of instability that comes to the rocket when they're trying to launch it. Winds are an active hazard for every single launch. It's just that usually the wind thresholds are not met. A hurricane, though, oh yeah, hurricanes will meet those wind thresholds.
I love the crawler. He's a spirit after my own heart.
Good old 3 miles per hour. And then the final threat from wind is wind shear loft. This comes from 2 factors. One, will the rocket be blown off course? Because by the time you're getting into the upper atmosphere, winds are blowing a lot faster than they are at the surface, both due to friction as well as the fact that it's easier for winds to get to high speeds higher up. Or will the rocket complex be torn apart at max pressure? For anyone that has listened in on a rocket launch and heard the phrase max Q, that is referring to the max pressure on the rocket That point, winds are very, very important. They do not want high wind shear at that point because that will cause active damage to the rocket. It'll blow it off course. And that means the safety officer needs to press the button that goes boom. And contrary to what people think, the safety officer really does not want to press the button that goes boom.
Yeah,
I would think so.
But at the same time, knowing, like,
yeah,
I imagine, yeah, I see you have this later on, but like a whole lot of, they have the rules in their head of like, if a number of these are broken, it is not a judgment call. That button is getting pressed.
Oh, yeah. I have been in the room where the missile gets effectively scrubbed. And it is, whenever that happens, it is deathly quiet.
If you don't mind me asking, if you know, and it does, you don't need to specify the launch site or anything like that, but like, what does the button look like? Is there a protective cap over it? Is there...
I do not know.
Okay.
I do not know.
It would be better maybe if it was just a nondescript button, if it didn't have the massive, like, press this to destroy rocket.
I feel like there's like a certain degree of reverence that such a device should have. It should be different. It should have a protective cover.
Yeah.
I would hope. I would hope that it's something like a 2-key system.
Yeah, you don't want to accidentally press it, but pressing it is also like there is a gravity to it. Like, it shouldn't just be a button. It's an important button because it's the blow up the rocket button, you know? Like,
yeah,
it's not just a button, it's the mission is over button. We need to blow up the rocket button.
It needs the wax seal like the AZ5 switch.
AZ5, yeah.
Yeah.
It's messed up that in my head now, every kind of mission critical button is just AZ5. Or it should make the staples that was easy sound.
No. Please, no.
It's the easy mental shortcut to make. And that is actually one thing that does come up when determining the weather constraints. So, question is, how do you determine the weather constraints? Well, the first thing is, what are the goals of the launch? Is this a crewed mission? Because if it's crewed, there are going to be a lot more constraints than there would be for the same rocket if it's uncrewed. The next question is, how complicated is the rocket? You have cases like the Falcon 9, which is, any rocket is really complicated. The Falcon 9 is relatively uncomplicated. You compare the Falcon 9 to, say, the Falcon Heavy, or the Space Launch System, or historically, the Space Shuttle. Those are really, really complicated launch systems. And they're going to have a lot more constraints than the Falcon 9 itself.
So just like dictated by the design of the rocket itself.
Dictated by the design of the rocket itself, each one is going to have different thresholds for what it can and cannot handle. The second question is, where is the launch site? A lot of launch sites are in the tropics. That is because they want to get as much momentum from the Earth's rotation as possible. But not every launch site is. One can make an argument that Cape Canaveral is in mid-latitudes. Meteorology terms, tropical, mid-latitudes, polar, that's referring to what atmospheric environments are causing the most active weather. In Florida is just far enough north to get what is called mid-latitude weather, so think fronts, mid-latitude cyclones, air masses, but also in the summer experience tropical conditions, not just tropical storms, but warm temperatures year-round, sustained prevailing winds. And then you have polar environments, of which I only know of one, which is Kodiak, the Pacific Spaceport Complex in Alaska. And I do not envy the person who has to forecast for that site. But across the United States, there are a number of sites, the most notable ones being Cape Canaveral in Florida. You have Wallops, that is in Virginia, that is a mid-latitude location. You have Vandenburg Space Force Base in California, that would be mid-latitudes. Ones that are not listed on a photo showing the spaceports around the United States would be the Reagan Test Site, that is Barking Sands in Hawaii, Kwajalein Atoll in the Marshall Islands. Other ones around the world are French Guiana, that's in the tropics. Baikonur in Kazakhstan is infamously in mid-latitudes to polar weather. Tanegashima in Japan is a mixture of mid-latitudes and tropical weather that they need to worry about. And Sichuan Launch Center in China, that would be almost entirely mid-latitude weather, but they have their own, they're going to have their own problems to worry about, and I don't know those details, both for my own sanity and safety.
We need to do more of a kind of audit, or just a fun check on the various Chinese CNSA launch sites, because all of them are very interesting, especially the one that keeps dropping hardware on towns. That's a fun one.
Yeah, it's not fun to see something with a giant plume of red fuming nitrate falling on a populated area.
Do they just not have the button over there? Like, what's the problem?
Well, no, these are these parts. So specifically, I don't want to go on too much of a tangent here, and this isn't from Jiuquan, I believe. These rockets specifically launch from Xichang, and I might be mispronouncing that. Xichang is one that is in like basically just the middle of China. Its launch trajectory and its downrange kind of drop zones are basically all in populated areas. This is the place that Intelsat 708 launched from, the rocket that famously plowed into a nearby village and killed at least 6 people, and then there's a shitload of cover-up and whether... Yeah. But yeah, as far as I know, Jiuquan is a good one.
This is not the good timeline.
Almost every launch site in the United States is about 45 minutes to an hour away from any major populated locations. Vandenburg Space Force Base is relatively close to Los Angeles, but that's still about 45 minutes to an hour drive away. Barking Sands is about an hour away from the nearest town on Kauai. Kodiak is out in the middle of nowhere, Alaska, and Cape Canaveral is 45 minutes from Orlando. They're all distant because in the case that a rocket blows up, well, you don't want Operation Bongo 2 from the 60s where the U.S. Air Force was just doing supersonic flights at low level directly over Oklahoma City and breaking windows. That opens up lawsuits, and you don't want lawsuits.
It is exactly the kind of thing that I would expect that would be the main concern of the government agencies involved. Is just like, yeah, but if they have money, they could sue us.
And a lot of government agencies are operating on really, really low amounts of money.
Yeah.
Like, the military-industrial complex is this constant flood of money that is never stopped.
Yeah, a fire hose.
The moment you get to a government agency, it is a tiny trickle, and you're trying to figure out how to allocate that.
It's the one way that space people can get access to the money hose. It is pretending that what they are doing is a weapon. It's how Korolev got started. It's how NASA got started. Pretend that your rocket is a weapon.
Yeah.
We need to talk about it sometime, but whenever Korolev, this is less well known, was at risk of losing funding for the N-1 Soviet moon rocket, he tried to pitch it as an ICBM that could launch 17 SAR bombas in like a giant MIRV spread. Just like one rocket to completely destroy the Western Hemisphere.
With this one neat trick.
So, those are some of the weather constraints. Let's look at an actual example. On the next slide, I have an image I pulled from NASA. This is the Falcon 9 Crew Dragon launch weather criteria. Like I mentioned, the Falcon 9 is a relatively simple rocket. Again, relatively is the key word here. So, what is the climatology for these constraints? Well, first, for winds, cannot exceed 30 miles per hour at any point during the launch. That's the limit for the Falcon 9. We want it to launch into an area where it's not going to be blown off course and not going to potentially damage the launch structure. Second is low lightning within 10 nautical miles. Again, you don't want lightning near a rocket. That causes things to go boom, and you don't want things going boom directly near you unless it's controlled. The third one is for possible recovery. In the case of an abort, they need to make sure they're able to recover the capsule. And that is referring to the ocean waves. I could not find any detailed information. I'm assuming that is proprietary to SpaceX. A NASA.gov article I found said they couldn't recover the capsule if the wave slope in the ocean was over 7 degrees. So I'm just doing a quick assumption. Let's just assume that it's 6-foot waves is the violation. Going by the Beaufort scale, that means that the winds over the ocean cannot exceed about 16 knots or 18 miles per hour. So let's just assume that the recovery site, the winds need to be below 18 miles per hour sustained. And then the last one is the triggered lightning constraints. That would be a bunch of cloud limitations. So that would be do not launch through a cloud layer greater than 45,000 or 4,500 feet thick that extends into freezing temperatures. Do not launch into cumulus clouds that have tops extending into freezing temperatures. That is triggered lightning. Do not launch if field mills or electrical sensors on the ground within launch pad exceed 1,500 volts per meter. Like, Cape Canaveral is the most censored launch site I know of, and there are about 39 of these field mills spread out all across Cape Canaveral, monitoring electric fields to make sure there's not a lightning bolt that goes down from the rocket to the ground.
Wow. So they've just got this fully mapped out, all kinds of sensors for this all over the place to just have, as best as possible, a constant knowledge of, like, the ground conditions, the weather conditions at various altitudes.
It sounds like they could detect if someone sneezed within range of the rocket.
They probably could, considering they also have closed-circuit TVs set up all over the place to watch everything as possible. The climatology for a Falcon 9 2, like, it varies. In the summer, wind is not a huge threat. Winds are relatively light during the summer, but lightning is really high during the summer. A low probability of violation during the winter, very high in the summer, and it's similar for triggered lightning.
Okay, so I was just going to ask what POV was there.
Probability of violation.
Gotcha. You mentioned, like, the risks being higher for some factors in summer versus winter and vice versa. Taking all of that into account, in your opinion or from your knowledge, which, like, summer versus winter, which are more likely to get scrubbed?
For Cape Canaveral, I would guess summer is more likely.
Okay.
Just because that's when you have the most thunderstorms in the environment. We'll get to that on a later slide, but Florida is the lightning hotbed of the United States. But going from the relatively simple Crew Dragon to something more complicated, the Space Shuttle. On the next slide, I was not able to put all of the constraints onto one slide because there are too many.
Oh no.
You can find the documentation for all of the ways that the weather could cause a space shuttle abort. So I will just read down a general list. So, wind. If the wind at any point during the shuttle structure exceeds 22 to 39 knots, depending on the direction of wind, that is a scrub. The wind shear constraints. If the winds aloft are at a certain threshold, they're going to scrub. I was not able to find the exact threshold. It said as it was sent to Johnson Space Center for calculations, so I'm assuming that that's just not public. Temperatures. No temperatures below 33 Fahrenheit. Challenger is why we know that.
Woo!
And the temperature on average cannot go below 41 Fahrenheit. Again, Challenger is the reason we know that. We don't want to have known that.
But they do learn. They do learn their lessons. Asterisk.
We learned the lesson and in the process traumatized an entire generation. Cloud ceilings. This one is actually not trigger lightning constraints. This is just visual rules and observation because they wanted the cameras to be able to track the shuttle and monitor it for any issues. So this is direct visual flight rules through 4,000 feet. They would have some exceptions through 8,000 feet that they would still consider it an acceptable launch window, since some of these are not hard restrictions of you cannot launch. And then they want no precipitation at launch time. If it is raining on the shuttle, they are not launching. Even if it's a light rain that has no possibility of lightning, they're not launching. And then you get the fun one. Sufficient landing conditions for the shuttle at all of the abort landing sites. So, famously, the shuttle did not have a, quote, safe abort in that it did not have a capsule that could separate from the shuttle structure. However, it did have abort protocols. If there was an issue where they needed to separate from the external fuel tank and emergency land, these were abbreviated as RTLS, TAL, AOA, PLS. There were a lot of different abort protocols the shuttle could have used, and only once was an abort actually used, and that was an abort after reaching orbit, because they didn't have the thrust to get to the orbit they wanted.
Oh, okay.
Each of these were airfields the shuttle was, quote, cleared to land at that needed to be within certain criteria for the shuttle to actually land because the shuttle was a flying brick. It couldn't maneuver, and you only had one shot at a landing. They needed specific criteria at all of these airports across the entire freaking globe in order for the launch to be cleared. So the space shuttle was really complicated for a weather forecast.
Watching a couple landings of the space shuttle, yeah, it does not fly so much as it falls and you aim it a bit.
Yep. So the space shuttle, I know, was notorious for having weather scrubs, and these are all the reasons why.
Okay. I guess kind of dumb follow-on question for that. If you have need-to-haves and want-to-haves, So like, you want to have visibility through 8,000 feet. You need to have visibility through 4,000 feet, things like that.
Pretty much.
Is there a points system for want to haves that becomes a scrub, or is that more of a judgment call? Like if you have a lot of your want to haves that have not been met, how many of those becomes too many? Is that a judgment call, or are there like regulations set down for that?
I don't know.
Okay.
Some of that might be up to the launch director, but that goes beyond what the meteorologist is responsible for.
Gotcha. Okay.
There are certain criteria that are considered essential to be green. This would be like lightning. There's some criteria that are considered that you want, but are not going to cause a mission scrub. This would be like flight rules. If it's just cloudy higher up, you can't get good visuals. It's not going to scrub the launch, but people manning optics are not going to be happy.
Okay.
It's that kind of threshold. And some weather constraints are at those thresholds. The ones that cause the main stress are the ones that are a hard go, no-go. So what are the other considerations? This is where you get into launch site, and this is where we get to the next slide. And this is where I have a graphic up that I'll need to explain. I'm referring to this as a summary of atmospheric scales. In general, the larger a feature is in the atmosphere, the easier it is to forecast and the longer it takes to change. This breaks down into what is referred to as mesoscale, synoptic scale, global scale. Basically, the larger the feature gets, the longer it takes to actually actively change.
Okay.
To refer to the recent Hurricane Beryl. Beryl was a relatively small hurricane. The problem with that is that meant it was very able to very quickly intensify and then weaken. Because the larger the hurricane gets, the longer it takes to intensify, the longer it takes to weaken.
So the smaller it gets, the more volatile, if you will?
Yes. And what makes it even more complicated is that all of these different scales feed into each other. You can make assumptions to not consider mesoscale when looking at synoptic scale features. Like, you're not considering a smaller thunderstorm when looking at an extended cold front that's going across the entire United States. But that thunderstorm is feeding back into the cold front and changing it. So that's where a lot of complication comes in. That's where a lot of stuff and assumptions and models come in. But when you're doing just hard math or making an immediate forecast, if you're looking at the cold front in general, you can kind of assume that that thunderstorm doesn't exist. It's just so that you can actually make that forecast.
Okay.
And the reason that I spent so much time talking about tropical versus polar is because the scale of the environment really comes into play there. In the tropics, you're looking primarily at mesoscale features. You're looking at thunderstorms. You have low wind shear. You have pretty consistent winds in the tropics, but you get frequent lightning. You get thunderstorms that develop and collapse very quickly because everything is driven by surface heating, whether it's surface heating of the ocean, surface heating of the land. You have land and sea breezes if you're along the coast, and most launch sites are along the coast because they don't want the rocket stages falling on possibly residential areas.
Got to get that Xi-Chang mindset.
Yeah,
that grind set, baby.
we gotta do like the CNSA does.
Jesus Christ!
This is the weakness of the capitalist West.
The East is red.
The East is orange and fumey.
Oh my god.
Oh no.
The East is RFNA. Yeah. Oh god, perfect. The East is red, brackets fuming nitric acid. Okay, cool. I can work with this. This is a sticker idea. Got it. Awesome.
What kind of remix is this?
Explosions like it's the 1812 overture going off in the background of the Soviet anthem.
There's actually nothing more patriotic you can do than have your house be destroyed by a Long March 2B first stage. You get a finder's fee, don't you know?
Being instantaneously obliterated for the party.
But from tropics, you then get to mid-latitudes, and this is synoptic scale. The considerations for synoptic weather, it largely depends on which coast you're on and a lot of the local topography. The winds are usually lower in mid-latitudes, but when you do get high winds, you get them for longer periods of time. but you also get extended periods of long-lasting wind shear. Mid-latitudes are where the atmosphere is very heavily dominated by where the jet stream is located. So this is where Vandenburg becomes an interesting consideration for launch sites. Vandenburg does not get a lot of lightning, and Vandenburg, in terms of a launch day forecast, well, it's going to be most likely 0 or 100. The problem is, it's 100% probability of violation because the jet stream is located directly over it. And if the jet stream's over it, you're not launching because the wind shear is crazy.
I was actually about to ask about that because, like, with launch sites, especially as bigger, better, reusable rockets are coming online, launch tempo and like the ability to launch rockets quickly to a reliable schedule is going to become increasingly important. And I wonder then if that's like a benefit to mid-latitude launch sites, is that I guess you do have a fair point in that, like, if the weather is nice, then you know 0% of failure, have at it. But then there's also the risk of, like, for a solid week, no one is launching anything, right?
Yeah, that's the problem. Tropical sites, yes, the weather is a lot more volatile in the immediate term, but if you have a launch window that's about 2 hours, you're probably going to be able to find a hole to launch. It's one thing I do touch on later on. The GOES-U launch that occurred in March had a 70% probability of violation just because Florida in the summer, there was a front nearby, you're expecting to see a lot of development for thunderstorms, but they found the window. There was only about a 5-minute hold before they were able to launch. The issue with forecasting for Vandenburg or Wallops is, yeah, you're probably going to be 0% probability of violation or 100% probability of violation. The issue is when you're 100%, you're 100% for a week. Vandenburg especially, if you have an atmospheric river going into the Los Angeles area, you are getting heavy rain, you are getting mudslides, you're getting flooding, and you're not able to launch for a week. You're not launching until that atmospheric river is out of the area, and the jet stream that helped fuel it is also out of the area.
Just going into the hangar after like a week of no launches at Vandenburg, and there's just like 12 rockets all lined up ready to go to be launched with like back to back to back to back.
And then you get to Kodiak, which is in the polar environment, which is the cursed combination of both.
Oh, God.
You have cold temperatures, you have a relatively low lightning threat, you have an absurd wind threat, because Kodiak is right along the northern end of the Pacific Ocean. Kodiak gets a lot of mid-latitude cyclones that move into the Gulf of Alaska that intensify to sustained gale force, which are hurricane force winds for days on end, as well as all of the logistical problems from being, on the Aleutian Peninsula.
Also, morale issues. Your crew has to live in Alaska.
I was about to comment, like, Alaska just feels like the worst one.
I was joking about that, but no, like, that would legitimately have to be, like, your launch crew is living not just in Alaska, but in this, like, middle of nowhere peninsula.
It's not even just Alaska. A lot of launch sites are in the middle of nowhere.
Right.
And morale is a problem. Logistics are a problem. Because you've got to get all of the equipment to launch it out there. If this is a launch where you're moving everything out there, like the example is the first SpaceX launch that was on Kwajalein Atoll. They had to move all of the equipment out to Kwajalein, which is halfway between Hawaii and New Zealand. Jesus. It is in the middle of the ocean, in the middle of nowhere.
An absolute nightmare.
It is a massive logistical challenge.
I am now wondering with polar launch sites because polar launch sites, obviously, the higher up you go in latitudes, the easier it is to launch to orbits with roughly that inclination. So if you go to a polar launch site, it is significantly easier to launch to a polar orbit. But I do legitimately wonder now if the benefits of going to of getting easier access to a polar orbit is worth the downsides of fucking cursed weather, logistics, and all of that, whenever you could theoretically just launch to a inclined or near equatorial orbit and then just like shift your inclination from there. You'd burn a lot of fuel, but you don't have to go to Alaska.
Kodiak is the only polar launch site I know of.
Yeah.
They are also pushing for Canso, Nova Scotia. That would definitely be mid-latitudes, but there's been all this talk for a long time, maritime launch specifically, this idea that they are going to launch refurbished rockets out of Nova Scotia in Canada that I think is probably not going to happen.
I mean, good luck. Do they want to recreate the Halifax explosion?
They're close enough. Yeah, they could do it.
I talked a good about Florida and the problems there. If you want to go to the next slide, that is an image I was able to get from the SPC, or Storm Prediction Center. This is the afternoon lightning climatology across the continental United States.
Oh, no.
It's listed as 19 Zulu to 23 Zulu, Zulu being Universal Coordinated Time, Greenwich Mean Time, Military Time, whichever you want to refer to it as. And the fun fact is you can look over Florida and see on a given day over 4 hours, there is over a 70% probability of a flash south of Tampa. And Orlando is also in an area of very high frequency of lightning. So this puts the quote from the 45th Weather Squadron into context. Florida gets the most lightning across the United States, and it's not even close. It is a truly insane amount of lightning that you get in Florida on any given day. And that's just because it is a peninsula that is stuck in the tropics, oriented north to south, with warm ocean water on both sides. You have sea breezes that move inland, meet in the middle, produce lightning, and that produces outflow boundaries that go across back to the coasts, which carry thunderstorms. And you just get that consistently during the summer.
It sounds like a thunderstorm incubator.
It is.
This is how stars get made in these like stellar nurseries, except it's just Florida just churning out lightning. That's all
Florida
it does.
Churning out stars.
Just like watching some little cloud form, and it's like, oh, it's so beautiful. That's its first flash.
When I've talked to meteorologists who live in the Great Plains or Northern Plains and mentioned that I was interested in tropical weather, their response was, well, I wouldn't be because it's just boring. You have Q by 3 and thunderstorms by 5. That's just your summer forecast. You're done. You don't have any challenges. It's not interesting anymore.
I was going to say, you mentioned I think it was the 45th Weather Squadron.
Mm-hmm.
That does sound like it kind of makes their job easier. Definitely not easy, but like, are we going to get lightning today? Yup. Guaranteed. Yes.
It's easier and more difficult because you're going to get lightning. It's a matter of figuring out where it is, when it is, and if it's meeting your window. And that is the challenge.
Better to just be in Vandenburg and just say there is no chance of lightning for this entire week. We can ignore, like, we don't need to consider that. Whereas with Florida, you have to be dodging, like, all right, so there is going to be lightning, but it's going to be a couple of miles that way. Is that close enough?
It's a trade-off. Every launch site has trade-offs. I wouldn't say Vandenburg is better or worse than Florida, because the problem for Vandenburg is if you have a condition that is just hard stopping any kind of launch, if you have an atmospheric river or the jet stream is just directly over you, you're trying to figure out when that is moving, because every single day you are scrubbing, every single day you are delaying, that is millions of dollars in terms of lost man hours and additional pay for people to just be on call ready to go.
Oh, yeah.
That is the stress you're dealing with, and you need to figure out when that feature is moving, because you're going to try and launch the earliest possible time, because every single day you're not launching, that's millions of dollars you are spending.
I'm just learning that every single launch site has some benefits and some incredibly costly downsides.
Yep. It's a matter of mitigating the problems and figuring out which is actually going to work the best. And in general, Cape Canaveral has worked out the best. Even though it is the lightning hotspot of the United States, it's got the best benefits, both in terms of being able to do equatorial launches, because Vandenburg can't do launches to geostationary orbit or more equatorial launches, because that's going to go over Los Angeles and Arizona and New Mexico.
I love doing a retrograde fucking launch to the equator. Just go the other way. Just go straight. Who cares if it's going to be another like 2500 Delta V? Just burn through it.
Just burn it, idiot.
We don't want to deal with thunderstorms, so we're going to load it with so much more fuel, make it so much more expensive, because we don't want to try and launch with a thunderstorm nearby.
We are using an SLS, the payload, this CubeSat. We are going to need every single bit of Delta V.
I don't care how many solid rocket boosters we're putting on this
launching
thing.
from Vandenburg.
We're launching from Vandenburg, and that's final.
Don't make me turn this rocket around.
So if we could go to the next slide, I came up with something just for pure comedy purposes, with a hypothetical. How would a Falcon 9 launched for Project Argus, everyone's favorite nuclear death snuggie fare? What is the climatology for launching from the middle of the Atlantic Ocean?
Just flying straight into the South Atlantic anomaly, hell yeah.
I think it's a very easy way to understand. This is not very good. This is a very bad launch site. So, without considering the funniest imagery of this, let's just go through it. Wind. You have all of the violations. In the South Atlantic, I was able to do a quick reanalysis to figure out what the average wind speed is at about 40 degrees south, 40 degrees west. The average wind speed is about 18 to 26 miles per hour year-round.
Jesus.
That's not great. And that is at the surface. Once you start getting up to about 200 feet, you are getting in higher in the boundary layer, and the winds decrease on a logarithmic scale when you get to close to the surface. Going up to about 200 feet, the winds are a good bit higher. Wind shear. All of the violations. You're in a mid-latitude environment. You're over the ocean, meaning you are seeing the jet stream aloft. It's a bad time.
Just watching your nuke, like watching the ground track of your nuke that you are trying to detonate in the sky, and it's drifting awfully like far away from you.
Yeah, I was gonna wait until all these explanations were finished, but like I'm having brainworms again of like there must be a meteorologist on board every naval vessel and submarine.
Oh, they're it.
These are things that probably are factored in. Like a nuclear submarine could be anywhere at any time. And it's like they could have to launch at any time.
I don't know if there's a meteorologist on nuclear subs. I know there's a meteorologist on there's a team of meteorologists on every single carrier. But I don't know what size the ship needs to be for the Navy to go, okay, we need a meteorologist there.
Well, I'm just thinking about like an SLBM. Like, does that just punch through all of the weather conditions, or are they just...
No, it's going to be affected. It's going to be affected.
But I imagine they just, instead of having to deal with windows, like it would definitely be affected and pushed around and whatnot. I just have to imagine that they load it with enough delta V to just like punch through and just redirect the course.
That's what I was
and
going
at that
to
point,
say.
You're not really caring about fine precision.
Yeah, if you're just aiming for like kilometer accuracy, or especially like if you know that you are going to reach space and then you have your little like transfer stage and you can just kind of like puff the cold jets, you can probably correct at that point. But yeah.
That's what I was going to say. The performance envelope of an SLBM is I'm going to scream as fast as I can into low orbit and then drop.
So the other considerations for Falcon 9 Argus, ocean waves. Oh, you're getting all of the violations. Wave heights are directly related to wind speed. The higher the winds, the higher the waves. You're getting really high, really strong waves, and waves in the South Atlantic are infamously brutal. Plus, you're in the middle of the ocean. You're getting ocean swell from all directions. Swell from hurricanes that are developing in the tropical Atlantic are going into the southern Atlantic. So you have the wind waves, in addition to waves from any given hurricane that's developing between the Windward Islands and Africa. They're going down into the South Atlantic. So this is not great. The only criteria for a Falcon 9 launched from Project Argus's location that's good is lightning. And you're actually getting good odds.
Hey, great success.
When you're out over the open ocean, it is much more difficult to actually get lightning than it is when you're over land. A lot of this is just due to creating a temperature difference and thus a pressure difference between areas of land that are heating up faster than areas over the ocean.
Okay.
Plus, when you're getting further south, when you're over the ocean, you're not getting as many little cloud aerosols that make it easier for clouds to form. So it's more difficult to even get clouds forming in the first place.
Bit of a derail question. Like, what is a cloud aerosol there? Like, is it the...
Cloud aerosol is just referring to a non-water particle that water droplets can attach to.
Oh, okay, so it's like the initial condition. It's like a little bit of dust that water can cling to, and that can kind of form the snowball rolling of a cloud. being created.
Yep.
Correct? Okay.
Whether it's a dust particle, a little like a particle of vegetation that's been lofted into the atmosphere. A cloud aerosol is just anything that a water droplet can deposit onto to start forming a cloud.
Gotcha.
Also, I was going to say, I just have the mental image of the weather crew on the Project 9 or Project Argus vessels just wolfing down cigarettes saying, no, you can't launch. No.
But at the very least, thinking like, all right, well, at least we don't need the lightning rod ship. Trying to pitch this to your superior officer.
All of this is also assuming that the Falcon 9, which is 162 feet tall, is mounted on a ship that is
wiggled around
in 9-foot waves coming from any direction, veering wildly around.
Yeah, you just have to be ready to launch really quick when it's roughly pointed upwards.
I was thinking about what I know about the North Sea, and I'm like, wow, I guess the Atlantic is just a bitch all around, because like it's just like the waviest motherfucker on the planet. Like
any area in the open ocean is a bad time if you're looking at waves. You want something around you to block the waves. That's one of the only reasons the Florida Strait is decent. You have Cuba blocking waves, you have the Bahamas blocking waves, you have the U.S. continent blocking waves. If the Florida Strait didn't have all of those waters would be terrifying.
I'm thinking then it's like, God damn it, Moon, you're ruining it. And then I'm immediately thinking about Interstellar.
Well, in fairness, we don't have black holes to worry about.
We don't have a black hole, several kilometer high wave to have to worry about.
Yeah.
Oh.
So what goes into providing weather support? We've talked about weather criteria. We've talked about launch constraints. This goes to the next slide. I have two pictures here. One is of a weather balloon shelter. There's a weather balloon being inflated with a second one ready to launch. And the second picture is a picture of one of the National Weather Service WSR 88D radars.
My favorite.
So the first one is, it's just logistics. It is a logistics nightmare. In terms of weather sensors, are they set up? Who is providing them? Do you have anemometers set up across the area? Do you have field mills set up? Do you even have field mills in the first place? Do you have any lightning detection systems? Do you have any thermometers? If you're launching from a place like Cape Canaveral, all of that is already set up. You don't need to bring a bunch of equipment out there. If you're launching from French Guiana or another launch site, you're going to have to bring that equipment out there. You're going to have to maintain it. You're going to have to transport all of it out there. It needs to be set up. It needs to be maintained. It needs to be quality controlled. That is staff you need to worry about. That is transportation costs you need to worry about. And then radar. Is there one at or near the site? If not, who's providing it? Are you getting it? Do you have radar at the site? And that means you're trying to figure out, are you transporting a radar out there? Do you own a radar? Does somebody operating the mission own a radar? Who is covering this? You need to figure out all of those logistics. Then you have weather balloons. The reason weather balloons are important is those are the only way we can measure wind shear. What is the release frequency? For launches from Cape Canaveral, before a launch, they are releasing one weather balloon every hour leading up to the launch. Is the system equipped to handle two balloons at the same time? Because for a weather balloon to complete a flight, it typically takes about 2 hours. So you've got that to worry about.
And audience, quick context there. For weather balloons, a lot of that sending various kind of sondes up into the atmosphere is because otherwise you don't really have good data on what the weather is like at certain altitudes. So the best way to do that is to just send a balloon up and at 10,000 feet, what's going on? At 20,000 feet, what's going on? 30, 40, etc. And transmit that back down. I guess on a busy launch day at Cape Canaveral, are they like, yeah, you mentioned like one of these every hour. Are they just trying to keep like as good a registry of the weather as possible?
Yep. They are monitoring for any wind shear changes. They are monitoring the wind shear just before time of launch, at launch, and even for later reanalysis, knowing what exactly the rocket is flying through. So they still launch another balloon at T-0, even though the mission is already going.
Okay.
They still want to know what exactly the rocket's flying through.
So if the rocket gets pushed off course and they don't know why, they can go back and compare against that data.
Yep. And then satellite data. How much data are you pulling in? Are any polar orbiting satellites nearby? Where is the closest geostationary satellite? Because that changes what data you can use to monitor the weather. Since geostationary satellites, the further you are away from it, the more atmosphere you're looking through, the more you get horizon problems. For Florida, that's not a huge issue because goes east is very nearby. But if you're getting to one of the more remote sites, or Kodiak especially, then geostationary data is not as good. You're relying on polar data more. And then finally, if it's remote, how long are people staying out at the site? How long do you have to deploy people to French Guiana if you're launching out of French Guiana? Because that's an additional cost. That's an additional thing you need to worry about. And with the weather balloons, how much helium do you need to send out there? Because you're not transporting hydrogen. And because it's helium, you need to buy that helium. And helium is expensive as frick.
Just, yeah, shipping out like a load of casks of liquid helium to this place and just like, yeah, have fun. You're going to be here for a few weeks.
All right, you've got to figure out where to store all of these cylinders of helium because we need that for the launch day. And that even comes to what type of balloon you're using. Most launches are just going to use the standard weather balloon that is used by the Weather Service, any weather organization across the world that releases 2 balloons per day. If they want to go higher, they need to, that amount of helium increases exponentially. If they're trying to get to 125,000 feet as opposed to 100,000 feet, that is 3,000 grams that is 3,000 gram balloon. That is a lot more helium than the helium used for a standard weather balloon.
Oh, I'm hearing about all of this, all these logistics, all of these sensors, and I'm really thinking, you know, they could have kept it simple. They could have kept the good old Baikonur Teoratam method of guy standing outside, lightning detector, guy stand outside, temperature sensor, that guy, he can tell you exactly how hot it is.
This is just the weather rock with extra steps.
Thing is, under our glorious capitalist state, I would expect there are companies that are trying to do that.
Just like get away with the bare minimum.
Safety officers and ground safety officers will actively start screaming at them if they try to do that.
Godless communists, all of them, insisting I have things like regulation and safety.
And taxes.
Insisting.
And that I am not the king of my own fiefdom. This isn't just feudalism too.
You are right, though, that I am shocked we haven't gotten to the like what was it called, the Titan submarine, like guys imploding themselves at high altitude or just getting vaporized by superheated plasma because they relied on the time-honored tradition of guys standing outside with a walkie-talkie to handle all of their launch forecasting.
I think just because doing any launch involves so much coordination with the FAA that Mr. Death Sub would have to go through so many regulations before they are even allowed near a launch site. And people that are actually manning and organizing launches, the moment somebody like Mr. Death Sub approached them with something as hodgepodge as that, their response is, no, go away.
You don't understand. Regulations stifle creativity.
Just imagining someone sitting at the launch seat of a space plane and just reaching forward and then grabbing the little Xbox controller. Let's go. Ignition hits the X button.
Meanwhile, the ground safety officer screeches at them because they don't want to be responsible for trying to figure out to get all the money to completely repair a blown up launch site from something that is just hodgepodge together.
I'm not worried about your safety at this point. You're gonna find a way to do yourself in somehow. I'm worried about our surroundings when you happen to do it.
I'm the one responsible for making sure that this launch site can be used in 3 days. If you do this, I can't do that.
I'm gonna have to hose all the Nadellan soup out of here, you asshole.
Yup.
It's the same Xbox controller they used on the Titan submersible. They hit the turbo button and the plane exploded.
It would actually be kind of interesting if the launch abort button wasn't a singular button, but you had to put in like a cheat code effectively on a controller.
Mortal Kombat finisher.
Konami code.
I'm joking, but that would actually be more secure than I would, like, even maybe like a 2-key kind of thing. You have to deliberately do like multiple steps. You cannot do that accidentally.
Up, down, down, left, right, A, B, start.
Just like, oh, like what was it? What was it again? Was it A, B, A, X? What?
Yeah, but Quinn, you have to deliberately do the song and dance while under pressure of having to very quickly very abruptly interrupt your mission. So.
Hire a gamer. I could do that when I was like 9, and I was under pressure back then. The reason I was cheating was because I was about to lose.
Good old Contra. That gets into the day of launch concerns. So the next slide. I do have the photo of the GOES-U launch. I brought it up that it had a 70% probability of violation. On launch day, what are the concerns? Well, the first one, how predictable is the immediate weather? Again, the smaller the feature, the higher uncertainty. If you're dealing with thunderstorms, it's not very predictable. It is not as predictable as dealing with, say, the jet stream. It's more difficult the smaller the feature gets. The next question, what is the launch window? The GOES-U launch was given a launch window of 2 hours. That's relatively large for something that is going openly into orbit. So even though they had a 70% probability of violation, they were able to launch right within the launch window, and thunderstorms moved in after that.
So to be clear here, probability of violation, that number is like, is that the probability of violation within, like, happening at one time within that 2 hours? Is that the probability of, like, at any given moment, and you just have to, like, wait for your 30 seconds to come up on the dice?
Effectively at any given moment. And within that window, a lot of safety officers, they want to have the window from the time the countdown resumes to the time of launch. So this could be not a 30-second window. They may be looking for a 30-minute window just for safety purposes.
That feels like there's still a lot of variance, especially if the probabilities of violation are so high, or it's like how do you really know at that point versus like it seems good enough, we have to take the chance and just do it kind of thing.
Well, that gets to the ISS, because the launch window to the International Space Station is 40 seconds.
Okay. I get it. It's for safety. I get it. And you're trying to rendezvous with an object in orbit already moving at incredible altitude and speed and whatnot. But like, how do you hit, like, sorry, I have been floored by this. Okay. So like okay. Dumb question. What happens if you do have a probability of violation prior to a launch to the ISS? So you've got a 40-second window.
And they need this food shipment now, or they'll go insane and tear each other apart.
They scrub to the next day.
Okay, so
that's basically what it is. Every launch is going to have backup days, and in that case, you scrub to the next day.
Okay, so there is no hope of redoing, like you're not going to scrub at 39 seconds and say like, all right, restart the count within the next 30 seconds. Like if it's getting scrubbed, there is no hope of a second go that day or within that window.
For the International Space Station, the issue is it's at an orbit that is able to receive things from Baikonur, and because of that, that orbit is extremely challenging to meet from a launch site in Florida. They only have that 40-second window to launch something to even be able to rendezvous with the International Space Station.
Does Baikonur have like an easier time then?
I do not know. I would wager a guess that it's something similar. Because at that point, you're dealing with orbital dynamics.
Yeah, the ISS is not in an ideal orbit for either Cape Canaveral or Baikonur. It's at like the 50-50 mark between them.
Mm-hmm.
So I would imagine they have a similar, like they have the opposite problem on the other side, effectively.
It's a painful compromise orbit that no one really likes, but that's the way the ISS was set up. So the goal is to find the window in the weather. And like a lot of stuff in meteorology, it's either extremely low stress and you don't have a lot of problems going on, or it's extremely high stress because there's active weather and you are stressing out trying to find that hole. And from somebody who has had to say the weather is not good for a launch, the meteorologist feels worse about it than the person making the call to say, no, we're scrubbing.
I can imagine a lot of rocket engineers, a lot of people on the launch crews are very much in favor of the, no, fuck it, let us go.
It varies from person to person. Most of the people that I've interacted with are a lot more conservative in the sense of, no, if the weather's bad, we're scrubbing. If the weather's not great, we're scrubbing.
The payload folks are very much in favor of not blowing up the rocket.
Oh yeah, I do not envy the person who was the main launch forecast for the James Webb Telescope, because that would have been such a stressful forecast to make. Is you have $10 billion on the line, 15 years on the line, and you're looking at the forecast going, oh my god, what is happening? Like, if I get this wrong, that amount of money is on me.
Yeah.
That is an unimaginable amount of stress. But any launch, the cost of delaying one day of like $5 million, say, is far, far less than the cost of losing the rocket entirely. Because that can be anywhere from $500 million to multiple $1 billion.
Yeah, always better to delay.
So this is again, to put more succinctly, this is a no on the dehydrated tortilla shipment.
Probably, yeah.
And now this gets me thinking, because it's like, if the logistics of the ISS is this complicated, which again, I guess mostly because it's an orbiting body that's just moving really fast. But I'm like, okay, the logistics of a supply chain to a lunar or Martian colony, like, is probably going to be, I would imagine realistically, like a multinational thing, because then you'd have more launch windows, more frequent launches, just like.
It would have to be, I think, because the logistics behind all of this is incredibly complicated and restrictive.
It would definitely be different, I would say, because like once you're out in orbit, then you're purely dealing with orbital mechanics. So you do still have like different kind of, my window for translunar injection, stuff like that. You have to set up what kind of communication stations and satellites are visible to the payload at different times. Yeah, I'm off on a little like, ooh, this is in my wheelhouse now rant, but yeah, nightmarish.
And now I'm thinking like, lunar colony is growing and is like in the weird in between phase of like self-sustainability.
They can make their own tortillas.
Yeah, but like I'm thinking now, it's like, okay, imagine now for a moment, like, what is the equivalent of the lunar highway between Earth and Luna? Because like, what if the frequency of deliveries is frequent enough that there is, granted, like, to scale anyway, because it's still a lot of space and distance, but like, imagine just like a stream of just deliveries and returns. And
mentally, I picture it as something similar to like the attempts from Iceland or Scandinavia at founding Vinland in the 11th century, and the difficulties in actually trying to maintain that just because of the logistical challenges of resupplying either colonies in Iceland or what is now Nova Scotia, and that it just wasn't tenable.
I imagine you would definitely, like, there's different ways of getting payloads out there. Like, there's the idea of just launching payload. One thing you can do, like, if you're trying to build up a base, a colony of some kind, one of the proposals is that you never return things. Like, if you launch a spacecraft out there, you would launch a habitat and you would just pack it to the brim with, like, food and consumables and stuff. And then it would just land and cool, you now live in the cargo container. Like using dual use things like that. Although there is also the idea of like cyclers, ferries effectively that only exist, that only travel back and forth between low Earth orbit and low lunar orbit, and just serve to give that translunar injection back and forth.
I was going to say something like, I'm wondering if because it seems more efficient if it's like there's just a thing that waits up in orbit and it just carries the stuff back and forth instead of landing back on Earth or something.
All it does is just give it the next kick.
Andy Weir's The Martian intensifies.
And in principle, that is kind of how shipping anywhere on Earth works. Like if you're trying to ship something from continent to continent, whenever I get my cheap Lego, my knockoff Lego rockets that I get for really cheap, those are coming from China, and a truck takes them to the shipping location. A boat takes them across the ocean. Another truck takes them to near where I live, and then a further smaller truck, like it moves down the tiers of...
Your Legos are in a box, and that box is in a box, and that box is in a container, which is also a box.
Whoa.
And that goes on top of a ship,
just
which
a box.
Isn't really a box, but it holds boxes, and then it's like a little mountain. It's like a mountain where you started small box. And then you got big. But then you go small again, and so that's shipping logistics in a nutshell.
And I mean, even then, you could see things where if there's some, I'm just like dumb spitballing at this point, but like depending on the size of the cyclers of the ferries being used, you could have multiple rocket payloads being kind of bundled together to be sent in bulk, which would be the equivalent of like putting everything on a freighter, and then once it gets there, it'd be further farmed out. But still a logistics nightmare.
That is kind of what NASA already does. A lot of launches are just grouping a bunch of things on the fairing for any given launch.
It also recoups cost, and if you're trying to launch a satellite of 20 tons and your rocket has a 40-ton capacity, like, hey, may as well use it. It's going to go to waste otherwise.
Yep.
I hope that we have like a very fleshed out space truck in my lifetime.
Yeah,
the space F-150.
We just see space truckers like it's Cowboy Bebop.
The noble act of bringing stuff from one place to another in your large vehicle.
Problem is that may bring us into EVE Online, which is terrifying territory for everybody.
No,
Yeah.
I don't want to live in Excel. Don't make me live in Excel, please. I already do. I want
Chris,
to
are you
Are you
escape
referring
it.
to that as the birth of space piracy? Or is it more of like the hyper corporatization of space and space resources?
Space ultra capitalism.
Yeah.
So for weather overall, this gets to the last slide. Weather hazards are pretty well understood for rocket launches. If there's catastrophic accidents, it's typically mismanagement. I was only able to find one other case of triggered lightning causing the loss of a rocket, and that was Atlas Centaur 67 from March 26th in 1987. It was struck by lightning during launch, and the vehicle was lost. When I looked up the reports, neither the managers nor the weather team knew all the cloud constraints were for lightning. All of them thought it was icing. And because there was no communication there, well, they launched into a thunderstorm and the rocket was lost. The vast majority of direct problems to rockets nowadays from weather are just corrosion. Most launch sites are in the tropics, and that means they're exposed to a lot of rain, a lot of salt spray, and a lot of wind. Not necessarily lightning or wind shear, because, well, when you know the hazards are there and the cost of making sure that those don't destroy your vehicle is in the tens of thousands or hundreds of thousands of dollars, when the vehicle itself is something like 500 million, that's insignificant. Just pay the weather people.
Yep.
Pay the weather people to watch for stuff. That's not a huge cost.
They'll tell you your rocket's not going to die if you launch it now.
Yeah.
And also, like you were saying, just the fact of understanding, because these guys, Atlas Centaur 67, these guys had all of the restrictions. They had all of the do not launches laid out in front of them. They had all of the boxes to tick. And because they didn't know what some of those boxes were for, because they didn't have the qualitative understanding, they still fuck it up.
Yep. And that's one of the issues whenever anyone is sent out to a remote site. Every person just kind of intuits the weather where they live, where they've grown up, and that just becomes second nature and subliminal to them. If you're going from, say, North Dakota to French Guiana, all of your mental heuristics are wrong. Every single mental shortcut you can make involving the weather disorients you once you arrive at the launch site. And you're going to be off. You're going to be thrown. And this applies to meteorologists as well. You can theoretically understand, hey, this is what the climate is like. This is what it's like. This is what I'm forecasting. But all of your intuitive responses to what the atmosphere is like, it's going to be off because you just arrived at a place you don't truly understand.
As a person who lives in South Dakota, I don't know why you'd want to launch anything in North Dakota. It's too windy here, but if you were to pick between the two, you should launch them from South Dakota instead. We're better.
I mean, neither site is on a coastline, so that's already a no-go for launch sites.
What do you mean? The rocket will just crash in someone's farm and
North Dakota.
no, who cares about them? They're just farmers, you know.
Well, it's going to crash in Iowa, meaning it's going to land in a giant field of corn and become completely invisible to the huge water haze around the giant cornfield.
Iowa? Who cares about Iowa?
You've
you
attacked
know?
America's corn. Prepare to feel wrath.
This is just Interstellar.
We have backup corn. There's Nebraska right there.
The giant cornfields have actively changed where thunderstorms initiate in the country.
Jesus.
Do not underestimate them.
Are you saying that, like, the corn has the butterfly effect of changing where the storms happen?
One kernel blossoms.
Yes, because corn transpires so much water vapor that it changes where thunderstorms initiate in Iowa.
Jesus.
Dude, we need to get more reverent about corn than we are already. Like,
No.
power.
Destroy
the
corn.
power of corn.
Kill all kernels.
That ends the slides I have prepared, so if you have any additional questions or stuff I wasn't clear on, go ahead and ask.
No, you've covered everything really well. I'm now just wondering, like, all right, so Florida, weather hellhole. It is the thunderstorm incubator. Can we get them to grow more oranges? Can we suck all of that moisture out of the atmosphere and just like, can we put corn in Florida to just neutralize all of this?
No, you cannot dehumidify Florida. That is physically impossible.
It's impossible. You have ocean on two sides. It is always 3 sides. It's always going to be a humid swamp.
We need to requisition everyone's silica gel packs, and we need to just pile them around Cape Canaveral.
The nuclear power plant that just runs the world's biggest dehumidifier.
I'm having like multiple brainworms occur that it's like there's a cancer metastasizing in my brain. It's filling with like voids.
I've played the Left 4 Dead clone recently where it's worms. I know how that, yeah.
Yeah.
We're just going to build like the 1,000 foot tall, 200 foot wide silo, dehumidify, and just keep the rocket in there. My precious child.
We already have that. It's called the Vehicle Assembly Building.
On top of the crawler. It must be protected at all times.
So, Tenki, I know that it's like a human societal norm in the workplace to talk about the weather. When your job is to talk about the weather, what do meteorologists do? What's meteorologist small talk like?
Varies. A lot of meteorologists are just normal people to geeks, so it varies from topic to topic. When it's talking about the weather specifically, usually it's somebody talking about whatever extreme is going on. When Hurricane Beryl was occurring, even though the area I'm at was at no threat, basically we had a satellite loop of Beryl going at all times, just because it's fascinating. Like, yeah, it was not fun seeing a Cat 5 go into the Windward Islands, and not fun seeing a Cat 1 go into Houston. But people in meteorology, it's such a demanding course load in college for such relatively low pay that the only people who go into meteorology are the people who are really passionate about it.
Hell yeah.
What you're saying is, in so many words, workplace discussion still involves talking about the weather, even though it's your job.
Yep.
You go into the minutiae of the weather rather than just being like, hey, you guys, it's a little breezy over here today. Is it breezy over by you guys?
Pretty much. The version of this presentation that I'd give for work would go into a lot more detail about a couple of launch sites and the small local and mesoscale effects that occur. Like, this is an overview. I'm going nowhere near into extreme detail about, like, Cape Canaveral and the various things that can happen.
The thing for me is I'm always interested in like ranking things and finding the relative differences between like this launch site and that. And like, this has now got me thinking, like, I desperately want to talk to people and get an idea of like everyone's favorite launch site. And you definitely did lay out a lot of like pros and cons for all of these different sites, like Florida being the weather hellhole that it is, but then Vandenburg, it will also shut you out for months on end. It is so much that I had never really thought about. I don't know. We've talked about this before. This is why we definitely want to have like guests and experts on to talk about this stuff. Just the fact that behind every single launch is thousands of people, all of whom are doing